Hello, my name is Chattong Yubonpan, the student from Nn School. Today I'm going to present my project that's about the analysis of the light diffraction through the double slit by using the Fresnel diffraction formula. First, I will show about my outline that are the sequence of our presentation. First is the introduction, growing objective, methodology, going on to the lastly the future plan. If you don't mind, I will leave the question till the end in our presentation. First is the statement of the problem. Form I have the opportunity to join the TYPT project that was held in the 2018. There we have the interesting topic and the interesting problem that is the radiant lantern. That said, when we have the camera on take a picture from the source of the light, example in the sun, in this picture they will see the spike of the light that will show like that. And they said that it affects from the diffraction of the light and the interference of the light that we can observe. From the previous slide, that is necessary to make me have to tell you about what is the diffraction of the light. The diffraction of the light is the phenomenon that the light come and make the obstacle that the light cannot travel through. Then the light will have diffraction around the space that they can travel. In this picture, they will show the temperature. That one can explain from the Huygens principle, that is each of the wavefront that have the diffraction. Each of the point there will be the new source of the wavefront, and the sum of all wavefront that have the diffraction there will be the new wavefront, and the new wavefront that will be the interference in the scheme that we can observe in the x prime y prime coordinate in this point. In our work, I will use the Fresnel diffraction equation to explain the relation between the electromagnetic field of the x prime y prime coordinate with the E0 of xy coordinate. That the E0 of xy will show the function that the light or the electromagnetic field can travel through, and that will show the relationship from this equation. From this equation, you will see the integration in the exponential from the integration that I had to get it come out, and I will use the Fraunhofer approximate to make the term of x squared and y squared are easy to consider. And in this picture, you will see the blue of the circle that are the lengths. Then, normally the length will have the effect to the electromagnetic field of the left side and the right side of the length. That the electromagnetic field have the travel through and out. That will show this equation to explain this relation. Next is about our goal and objective. First is to understand and know about the diffraction of the light phenomenon. Next is to be the basic knowledge that we will use in our future work. The main projects. Normally, we can predict the result of the picture that come from the temperature. In this picture, we will show when we use the square temperature or the rectangle temperature. That will show you the spike of the light that are the four sides like that when we use the rectangle temperature. In the other picture, that will show the different form that we use in the same temperature that come from the Fraunhofer pattern and the different from the Fresnel pattern that I use from the reference. And in our work, I will do reverse of this because of normally we predict the result from the temperature, but this I will predict the temperature from the result that are the picture from the left side. Then I will analyze it about my double slit about the width of each slit and the distance between them, and I will compare with the theoretical value that I have find from the experimental result that are the picture. Our set of equipment is composed of the source, temperature, skin, and the short focal length. First is the source as composed of the the objective length of the microscope and the laser that we know and can control the lambda value. I use the objective length of the microscope because of the light that come from the laser that are the point, but when it travel through the objective length of the microscope, that will increase the area of the light that can attract the area on the temperature that will easy to make the condition that I have considered. Next is the temperature that I use this temperature, but in other I will close it with the back tape that there will not be have the effect in our result. Next is the short focal length and the skin. I use the lens because of it will make the condition that I have told you before about the action of the lens. And I use the CCD sensor as a skin because of the CCD sensor can capture and save the picture into the computer in the real time. Our calculation, the first is start with when I consider the distance from the source to the temperature is equal to U1 and the distance from the middle of the lens to the skin is equal to C, and U1 and C and the F range of the lens, they will have the relation is 1 divided by C is equal to 1 divided by F minus by 1 divided by U1. That is the lens principle. The electromagnetic field, there we have the 4 points that I consider, and I will show you in the point 4 that we can observe in the skin or the CCD sensor that can calculate step by step from 1, 2, 3, and 4. In this term, there we show the E4 or the electromagnetic field in point 4 of x prime y prime coordinate. And when we consider this term in the spiral frequency through Fourier transform, there will see there is the same function that I can consider as the picture or the electromagnetic field that we can observe in the skin. There will be the Fourier transform of the E0 of xy or the Fourier transform of the temperature. This all of the condition will be in the Fraunhofer approximate and the action of length that I have considered in our experiment. The first, the calculation of the double slit that will show the E prime of x prime y prime that we consider in the skin in this term. But in the picture we have captured in our result that will show the intensity of the light. And the intensity of the light is the product of E times E conjugate. That will be this term have the square, that will be this term. And when we consider in this picture, you will see the cos term or the interference term of the wave will be the subgraph in the side term. That can consider to more easier in the diffraction term. From this picture, I will show you how we collect the result. First, I will create the axis in the middle of the picture that cut the high intensity, and I will find the distance from this to the node and this to the node. Then n is equal to 1 to 2 minus 1 and minus 2, and I will show the graph that relation between the x prime and the n. The slope of this graph are really linear graph. Then the slope on this graph is product of c times lambda divided by d. Our theoretical value, I will have to find the value from the other experiment that will make me know about the real value of our double slit as A and D. Then I have considered like that. In our experiment, I will use the graph. I will change the C to the 7 value and use the find the D that we can observe the x prime and the n like that. This is the table we show the C in the other value and the D that we calculate compare with the D that we are the real value. The conclusion is when we have average or the value that we calculate, there will be the difference from the thing is 9.6%, and we can observe the specific of the opening from the image that I have collected. Our future work is the encoding image obtained from the diffraction of the light. I will use the picture on the screen to be the code that they are hard to hack because of if we use the other temperature that will make the other picture on the screen. Acknowledge this project will not be success if without the support from the assistant professor Chaitong Yubonpan from Khon University, Ms. Suphapon Wongviang from DPST and DPST program. Thank you for your attention. Thank you.